Yeah, Bernard will be leading the presentation on Numpy now, so it's recording, so you can start once you do that.
Is it okay? Now, is the font size okay?
Yeah, that's fine now. Yeah.
Okay.
Okay, thank you.
All right. Okay. So, as I said, I welcome you all for today's session in Women's Promoting Science to the Younger Generation workshop. And then today we are going to look at Numpy arrays for Python. As I said earlier, there are a lot of extension packages that are used for different purposes and operation in Python. And Numpy happens to be one of the commonly used extension packages for multi-dimensional arrays. And so Numpy is basically designed for scientific computation, and it's very, very convenient in doing this computation. Now, in our today's discussion, we shall look at Numpy in general, and I would say that most of you might have used Numpy before, and so such people might consider this session as a revision for them. But on the contrary, there might be other people who have not used it before or seen it before. But you don't need to worry, just relax and then we just enjoy the class. So by the end of this session, we shall be able to know how to create array, then how to use function arrays to also create arrays. And these function arrays such as a range, zeros, ones, and diagonals, they all help us to create our arrays without definitely entering arrays manually. We shall also know how to use the shape, to know the shape using the array.shape command, and then know how use slicing to obtain different views of an array. We did slicing yesterday, so it will solidify what we learned yesterday. And then we shall also look at how to reshape or flatten an array and then perform some operations on arrays. And then if possible, we shall look at some advanced operations. Now, I've also provided some source, for this notes. So you can click on the link like numpy.org to get to know more about Numpy. And also, you can also download these two books. It's also helpful. It can help you. Now, as I said earlier, Numpy array is a Python model that is designed for scientific computation. And it's also helpful to perform linear algebras and can be used to represent vectors or matrices. So why is it useful? Is it useful because it creates memory efficient containers that helps provide fast numerical operations. Now, since Numpy is a built-in function, we need to call it or by using a command line import numpy as np. And here we are using the np just for convenience because we just want to represent it as, always remember that, okay, we are using numpy, that is why we are using np. You can basically use any word of your choice. So in the first code text here, we import the numpy package. So we import numpy as np. So let me just run it so that I can have the effects of it in the next cells, even if I don't import it. So we shall look at creating arrays, okay, in 1 dimension and then 2 dimension. Now, when we talk about 1 dimension, we basically picture a line, a straight line. And then 2 dimension, you can picture something like a Cartesian plane, which we all know. We have the x-axis and then the y-axis. So in creating 1-dimensional array, one consider how to create a list, which we learned yesterday. So you create this list here, and then you just add your numpy.array, and then within the brackets of the array, you put that list that you've created inside the curly bracket, and you create. And that is all you need to do to create your 1-dimensional array. Similarly, if you want to create a 2-dimensional array, then you need to create a list of two rows, okay, where you have a first row and a second row. So that is, I demonstrate here. I create a first list with a comma, and then again create a second list, and then I put these two lists in a bigger list, okay. Then I add my numpy dot array, and then within the bracket of the array, I put this bigger list in that, and that is it. I create my two-dimensional array. This is very simple, and I hope all of us will get that. So here I just demonstrate that here. Yesterday as well, we learned how to create a variable. So I create a variable of y equals my numpy.array, and then I put my list inside the bracket here. Now, these elements here can be any element, can be like experimental records. It can be the pieces of an image. That is where if you're in 3D, like you can talk about MRI, the image of an MRI is a 3D. So it can contain such element here. So these are our first dimensional array. So when you run it, that is the result that we see down there. Now we can also look at the shape by just using the array, which is my variable here, y.shape, and it gives me the number of shape. Now here, shape basically gives you the number of elements in each dimension, okay? So here we have one dimension, so you can see that we have three. So it means that we have three elements in the first dimension, and here is only one dimension that we are looking at. We can again use y.endDime to basically know the dimension if you want to be sure of, okay, what dimension am I working with? Then this will give you your dimension. So we have one dimension here, and the length of the numpy y is 3. And yesterday we also learned that length of basically gives you the number of elements in a particular list. And here it is an array. Okay. So we demonstrate the 2D array here as well, creating a 2D array. So we import numpy as np. Now, basically, you see that I imported here. So even if I don't import down, I imported here first, and I run it in your local Python notebook. When you import it in the first line and you run it, it can basically work downwards, because in Python, your code goes by line by line. So what you do up can definitely affect what you do downwards. Okay. So this is how I create my 2D array. So I have it nicely here. So I print it out, and this is what I get. And here, if I want to know the shape, which I said earlier on, yeah, I have a 2x3, which gives me a 6. So you can tell like 2x3, so it gives you like 6 elements in that array. Now we move on to looking at functions for creating arrays. And here we are saying that, okay, if I don't want to enter my arrays or my result manually, what are some of the things that can help me create my array fast? And here we are going to look at arrange, linspace, ones, and others. So for a linspace, you have numpy.linspace, okay? Then you have a start and then an end and then a step. You can also have the same thing as numpy.arrange, just an integer to also display your array. Or for the arrange, you can also have a start, an end, and then the step. Now the difference between this and the linspace is that for the linspace, the step here gives you the number of divisions between your interval, that is your start and end, including both of them. But in the arrange, the step basically kind of gives you like, okay, if I start from 1 and I'm stepping at 2, it means that I'm going to avoid 3. I'm going to avoid 2, sorry, and move on to 3 and 5 and so on. So that is what the arrange does. Now, also, you can also choose to not to include the endpoint in your linspace by using endpoint equals false. Okay, and we are going to demonstrate that below. So the first one we look at is what numpy arrange. All right. So I create a variable that has a numpy arrange of 10, and I print, and this is what I get. Now you should know that in Python, the last digit is always not shown or displayed. So here I'm requesting of 10, but I have 9. It's basically work as a range, as you already know, but in Numpy it's an A range, okay? So basically it works as that. Now here I will demonstrate with a step, okay? So I'm starting at 1 and I end at 10, but I'm stepping with what? 2. So it means that I'm going to display 1 and then move on to 3, 5, and so on. That is clear. Now we come to the lane space where I have an interval 0 and 1, and then I have a step of 6. So which means that I'm dividing this interval into what? 6, including the start and then the end, all right? So as we can see, we can count 1, 2, 3, 4, 5, and 6, all right? Now, let's assume I don't want to include the end point. Then I can use this command here, endpoint equals false. And you can see when I print it out, you can see that I don't have the endpoint to be 1 again. Is that okay? Now, one other commonly used function array in creating NumPy is zeros. And this is very, very, very handy. So I create zeros vectors. Here I'm considering it as a vector, okay? Yesterday, someone asked, how do I do a matrix or something? So here I consider this one as a vector, and I need a zeros of 5. Okay, so I do numpy dot what zeros 5, and zeros vectors here is my variable. So I print zeros vectors, and this is what I get. I have 1, 2, 3, 4, 5 zeros. The same way I can do for ones. So numpy dot ones, I make 5 of it. Then I have that one here as well. Now, assuming I want to create an array which contains a set of like 3, all the elements I want them to be 3. What I could do is that I could just create an array of ones, okay, and then just multiply by 3. Now we shall look at um, operations on array later on, but I just want to use this one to give kind of a easiest way of creating that. So I just multiply this by 3, and you can see that when you print your vectors, you can see that you have 3, 3, 3, 3. This is so fantastic. It's easy to create. Now, if I want to create, let's say, a matrix of ones, okay, or zeros, I could here, you can think of the input as a tuple, okay? Not just here that we just have an integer. So here we consider it as a tuple. So I have, again, my zero matrix, okay, numpy dot zeros, and then I consider my input here as what? A tuple. So I have a tuple inside. Yesterday we learned about tuple, okay? So I have 5,3, okay? And then when I print my zeros, I have a 5 by 3 matrix here, neatly created here. Now, again, if I want to say, okay, I want to fill all these here by, let's say, 4 or 1 or 3, you just have to add it to that, which we will demonstrate when we are looking at operations on that. Now, again, if I want to also create ones, I just consider my tuple. I have my variable to be t, so numpy dot ones, and then I print my t, and I have my ones, a 3 by 3 matrix of ones. Okay. Then what if I want to know the identity? Like in matrix, when you're working in matrix, you need the identity. Okay, I need an identity to do something. You just do numpy dot I, like as in EYE or I, and then you put in your digits, your input, okay, and then you print your variable, and you can see that, okay, I have my identity here. So nice. Now the next thing I would want to talk about is diagonal. Okay, now let's say I have my matrix, and I want to input on the diagonal, I want to put 3. Okay, I just have to create let's say this 2 by 2, okay, matrix here, and I want the diagonals to be 3. Now let's say if I want to create a 3 by 3, maybe I can just increase it with that, and you have that on the diagonals. You can also specify your diagonal manually, okay? So specifying your diagonal manually, what you do is that you do numpy.diag, okay? And then within the brackets, you put, because you are putting in manually, we learned how to create an array, one-dimensional array or two. So you put the numpy.array, then you put a list inside, which we learned earlier on inside here. And when you run it, you can see that on the diagonal, this is basically what you really want to put in there. Okay. You can basically change it, you can increase it, or whatever you do at your own time. You can play with some of these things, and you can really enjoy it. Now, one of the other things which comes handy is also random numbers. Now, in creating a random number here, this one is considered as a uniform distribution. Python, the background of this is based on the uniform distribution, which is between 0 and 1. So when I generate a random number of, let's say, 5, you can see that all the random numbers I'm generating here are between 0 and 1. Okay, so you can basically, okay, let's say I can increase it as that, and I have my random numbers generated. Okay. Now we want to look at the basic data types that we have. And basically, Numpy at a default is a floating point. Consider a floating point as its data type. So even if you don't specify it, Numpy considered that, okay, I have it as data point. So I create my array here, and I want to know the data type. I just do a dot data type, and here a is a variable, okay, and it gives you that, okay, your data type that you have is an int in the 64. Here the 64 just depicts the operating system that I use, and in my computer I have a 64-bit operating system. Okay. So again, here I can also demonstrate that, and this is what a float, because I have 1.0, and this is basically a float. All right. Now, if I want to specify, I can say that, okay, I want my entry to be this particular data type. So I create my array, and here you can see that the input here are integer, but I want it to be a float. So I do my data type to be called a float, and you can see that, okay, my data type here is basically a float. Now, the next thing we would want to look at is indexing and slicing. And this is something that yesterday we looked at. And I want you to picture that when we talk about, anytime you hear about indexing and slicing, you have this bread that is on your center table that you have sliced them neatly. Okay. So if I'm doing indexing, then I want to take just a piece, one slice of it. But if I'm doing slicing, then maybe, let's say you can picture it as, okay, I want about 5 of it. So let's say I want to take 1, 2, 3, 4 of this one. Then if I take all these two together, then I'm doing slicing. That's the fundamental explanation that I can give, and I think this will stick to our mind wherever we find ourselves. So basically, but in technical term, when you're doing indexing, it means that you are trying to locate just a character or an object. But if you are doing slicing, then you need like a bunch of that. So we shall look at slicing in 1 dimension and then also 2 dimension. Okay, and in 2 dimension, if you are doing slicing, the first entity indicates a row, and then the second one indicates what the column. And here, this kind of format is for indexing, and this also is for slicing. So this array here that specified, okay, I have defined or given my array. Okay, so here it could be a variable name, or the particular array that you've defined, and you use the square bracket to do that. Now, you should also keep in mind that in Python, indexing starts from 0. Okay, so I'm going to create an a range, which I've linked. Is very easy. So I create this variable a, and I print. So this is my a. So I want to locate the first element here is what? A, then the curly bracket of 0, and I get the first element. So we learned this yesterday, so it's going to be easy for us today. And then if I want to locate the second element here, so this is 0, 1, and 2, okay, which is the third element, the third element, okay, so that is that. Now, if I want to index the last element, then I use negative, as we learned yesterday, to give us that. Now, I also want to, here we are doing slicing, okay. So I want from 0 to 2. So I want to index from 0 to 2. So it's from 0 to 2. So I'm going to have 0, 1, and then 2. So I have 0 and 1, okay, as my printed out. So we can see that. Now, this kind of slicing tells us that, okay, here I need all the entities, but I'm going to step by 2. So you are going to print all of them, but I'm stepping by 2. So you start from 0, you move on to 2. So the end, depending on the type of element you have in your array, you display all that. Again, here I start from 2. I want to end at with 9, but I'm going to step at 3. So you do that, and that one also gives you that. Now, this kind of slicing reverses your array. So I use the 2 semicolon here, and then I do -1, and it is reverse my array. So you can see that here, when I created the array from 0 to 9, but when I use this slicing technique, it reverses the array starting from 9 to 0. And it's also very helpful. Now in 2D, as I explained, the first column here is considered as what? The row, and sorry, the first, not column, the first element here is considered as the row, and this is considered as what? The column. And basically the indexing numbering is the same if you have one dimension. So it means that this first row is considered as 0, this is 1, this is 2. Now when you come column wise, this is also what? 0, this is 1, and this is 2. So if I want to index this line, this element here, 1 here, then it means that I need what? 0, 1, I need on row 1, and then I need on what? Column 1. So I index that and I print out, and this is the value, the elements that I'm indexing. Now, assuming I want to change any of the entity here, so we do combining assignment with slicing. So I want to tell Python that, okay, on column 1, sorry, on row 1 and column 0, I need that element to be 19. So on this is row 1, so I need 0, 1. So on row 1, and then column 0, I need this element to be 19. So you assign 19 to that slice, and you print out, and this is what you get. Very interesting there. So we continue with slicing, and here you can see that I have a variable which is equal to numpy.arange10, and I'm slicing it. I'm slicing it and then assigning 10 to that. Okay, so this is telling me that, okay, from 5 of this array, okay, so from 5, after that, each of the elements all there is going to be 10. So from 5 upwards or onwards, I want all the elements there to be 10. Okay, so I do that, and you can see this is the original array that we created. And from there, when we do the assignment, you can see that this is the element that we have there. You can also do backwards. So here I create an array of what? A range of 5. And then I do an assignment of what? The reverse of this array that I get to be that, okay, on the 5th element onwards, I want all the elements to be the reverse of the A range that I've created, or the array I've created. So I start from 0, 1, 2, 3, 4. Now here we said that the last element, which is 5, is not displayed. Okay, So that is my element in this variable. Then I reverse it and I assign them here. So when I reverse it, it's going to start from 4, 3, 2, 1, and so on. That is also nice. So we continue more with slicing. It's very interesting. So we have a variable here, x, which is a 2-dimension, and I print them out for you to see. Now I want to slice it. Okay, so I have the variable x, and here I'm saying that on all the rows, so I have all the rows. How many rows do I have? 2 here. And then the first column, I need those elements there. So it means that in each row, I'm going to print the elements on each row. And then I look at the column, so I'm on the second column. So all the elements here are going to be displayed. So we have that. Then I can do the same for the row. So I'm saying that on row 1, I want all the elements on the column, that column. So this is row 1, and all the column, I need all those elements there. So that is that. So I create this bigger array here for us to do a little bit more of indexing and slicing in Numpy, because it's very, very handy. It's very, very useful when you are doing, let's say, a complete programming. So I create this variable Numpy array, which is W, and I print them out first, and this is the output. And I want to locate here on the 0 row. So this is the 0 row. And then identify the third column. So I identify the third column. And then this is my third column, but I want to stop at the 5th column. So it means that here it's going to list all the elements, but stop on the what? 5th column. Okay, so it's going to you will not display the elements there. So you can see this is the first row, this is the third column, all the elements here. So you can see that you have 3. When you print out, you have 3 and 4. Now the next thing is, okay, I want to see the elements on the the 4th row. Okay, so I have 0, 1, 2, 0, 1, 2, 3, 4. Okay, so on the 4th row, I need all of the elements in there. So this is that. So I move on the 4th row. This is the 4th row, and then on the 4th column, I need everything there. So this is the 4th row, the 4th column. So it means that when I go to the 4th column, to the end of the column, so this is the 4th column, sorry, to the end, I have this. Okay, so I list all the elements there. When I come to the row, this is the 4th row, till the end of the rows, I need all the elements. So this is the first row, I list the elements, I come to that. If should this continue, then it means that it's going to list all the elements in there. So we have that. So you can pick those ones out. Now, this kind of skills is very important when you're doing, let's say, I think image processing or something. Okay. Now we want to look at the next one here, which says that, okay, identify the third column. So you identify the third column, and then you list all the elements in each row. Okay, so you identify the third column. So this is 0, 1, 2, 3. These are third column, and we list all the elements on that. All right. So when you print out, this is what you get. And this is the last one here is very, very interesting, and it's very tricky as well. So I'll take my time to explain that, then we'll move on quickly. So here it says what identified row 3. So you have to identify row 3, and then you step by 2. So you identify row 3, which is going to be the index 2. Okay, and then the semicolon. So anytime you use 2 semicolon, then you bring this an element. It means you are stepping after the 2 semicolon. So I'm going to identify my row here. So
Hi, Bernard, are you here? We can't hear you again. Hi, Bernard.
Deborah,
Yeah,
hello.
yes. Elkanah,
Yes, Bernard is here.
what happened?
His machine freezed. Okay.
Oh, okay.
Yeah.
Hello, can you hear me?
Yeah, we can hear you.
Can you hear me?
Yes, we can hear you. And
Okay.
Bernard, on the chat, they say you are too fast. So could you try to slow down a little bit as well?
Oh, okay.
Yeah.
All right.
So
Sorry.
I think you can go
Let me get
over
my mouse.
from the
Yeah.
indexing and slicing so that people will get
Okay.
it. I think they were not getting it well.
All right. So I'll go back there again. So yeah. So this part, right? Okay. So here, let me go back here. So I created this bigger. So I created this bigger list. Sorry, this array here, and here I have my variable w, which is the my array, and I want to print out. I want to take out on the first row. So this, I said that this 0. So this 0 here indicates the first row. Okay, the first row is on the laptop. It indicates the first row here. So as I said earlier on, Python index starting from 0. So the same idea. So the elements you see here before the comma represent the row, and then after anything you see here represent the column. Okay, so this implies that I have on my 0 row, okay, and then here this implies that I want on the third column to the fifth. All right, I want to print out those elements. So I identify my first row, which is this, okay, and then here this is what my third column, which is in Python is the fourth. All right, so 0, 1, 2, 3. Okay, then from 3 and up to 5, I want all those elements. But you should know that Python does not display the last element. It displays the element before the 5. Okay, so this, when you print out, this is what you get, 3 and 4, which is these ones. Now, assuming I want to locate this 44, 45, and 54, which we can see it from this side. What you do is that, okay, I want all the elements on this row, which is 4. So, but in the actual sense, when you count normally, it will be 5. So 0, 1, 2, 3, 4. All right. So on this row, okay, on this row, I want each element on this row to the end. So I locate this row, which is 4, but on the column right, which is also 4 here, I want all the elements till the end of the column. So this is the fourth, let's say, fifth row. Sorry, this is the fifth column, right? But in Python, it to take it as the fourth. All right. Okay. So this is fourth, and then the fifth. So you see that there is no number here indicating the stopping time. It means that from 4 onwards, I want all the elements column-wise to display. And here from 4 onwards, I want all the elements row-wise on the row. So this is row 4 here, you can see. And continue, the next one will be 5. So here I have 44 here, which can be displayed here. Okay, then you have 54. This is when you are considering the column Y, which can also be seen here. Then it moves to the next column. What do I have? I have 45 here. You can see that one here. This one is 55. You can see also that one here. So assuming I have another column here, then Python will continue to look at those element that you have here to also be displayed. But since I don't have, then it stops. The same way it comes to the row, I have 44 and 55. 45. So you have 44, 55 displayed. It continues, it goes to the next row. I have 54 and then 55. It displays them. So assuming again you have another row here, then Python will continue to display all those rows. Because you can see that after this semicolon here, there's no other number. It means that from this one and onwards, I want all the elements there on the rows. This also tells me that from this 4 and onwards, I want all the elements there column-wise on the column. I'm just hoping that that is well understood. So the next thing we look at is this one here, which is the array and then the semicolon. Now here you can see that after this comma, we have 2. But here we don't have anything. It means that I want Python to go through all the rows, okay? All the rows. But here I want it on only column 2, all right? Indexing 2. When I say column 2, I mean indexing, Python indexing method, not our normal counting, all right? So only column 2. So I go back here, I locate my column. This is 0, 1, 2, okay? And here it's saying that I want all the elements on the row. So I locate my column. This is 2. So I go row 1. What is the element on that column? Is 2. I go to the next row. What is the element on that column? Is 12. I go to the next row is 22, 32, and so on to the end. So when I print out, you can see this is what you get. I hope that one is also understood. Now the next one here you look at is here I want my second row, that is by indexing, but I'm going to step by 2. I'm going to move by 2. So we have that one here. Now here you can see that, okay, there is no number starting here. It means that I want from the beginning of the row, from the beginning of the column to the end, but I'm going to step also by 2. So, but here I'm going to start from row 2, okay, and then I'll step by 2. But in this case, on the column, I'm starting from column 0, but I'm going to step by 2. That is the difference there. So let's locate our row 2. So we have 0, 1, and this is 2. Okay. Now the next thing says that step by what? 2 on the row wise. So I'm going to step by 2. So this is my second row indexing. So it means I'm going to print out this element, which is what? 20. Then I'll step by 2 row wise. So it means that I'm going to skip this row and go to the next row and print out the elements there. Okay. So it means that this 40 will be printed out. Now, assuming there is another row, it means that I'll skip this row and move on to the next row. Now, we look at the column-wise also version to try to understand. Now, this is that from 0 to what? To the end. I'm going to step 2. So I go on my row column, which is what? 0, okay? And I'll step 2. But I'm starting from this row. So from this column, I move, I mix this column, and I display this which is 22. I mix this column and I display this, and so on. Then I'll do the same thing for this row as well. I mix this column and I display this. I mix this column and I display that. So when you print out, you can see that you have 20, 22, 24, 40, 42, and 44. That also gives you that. I hope we get it there. It's a bit technical, but when you finish, you take your time, you get it. So the next thing we look at is shape manipulation. Now, assuming I have created my array, which is a 2-dimension, and I want to change the shape. So when I print this array, I have this, okay, this 2-dimensional array. Now I want to make it a 1-dimensional, flatten it. So I just use this command, a.flatten or a.revel, and it's flatten it. It changes it to, let's say, 1 dimension. Okay, so when you print out, you have that, you have all the elements in one set. Now, assuming I want to send it back how it was, that is what we call the reshape. So I have this variable. So I'm using the same thing here. So here it was a two-dimensional array, which is this, and I shape it this to this. Now I want to send it back as it was. So I put this a dot ravel, which is the same as flatten. They all do the same thing. So you can choose the one you want to use. So I store this in this variable b. Now I want to shape this variable b dot reshape. Now note that the elements here are what, 6 elements. So the best way I could reshape is either 3 by 2 or 2 by 3. Now if you try to change it, let's say I don't know if I want to change. You're on GitHub. Oh, okay, so if you try to change it, then it becomes a bit, let me just, give me a minute. Okay, I wanted to change it, but sorry, this is not my laptop. I'm using Elkane's laptop, so I'm sorry about that. Okay, I wanted to change it, this for you to see, but I think maybe you can practice with it and try to see that. So if I try to change this, then Python will give me an error because the element I have here would not be able to reshape it in that format. So I can only reshape it either by what, a 2 by 3 or 3 by 2. And here it's be considered as a tuple. So when I print it out, I have that this, my B, is what I get. Now I can also try to resize it. And resizing is just that, okay, I want to increase it or add other elements of form, which in this case to be 0. So I create another Numpy with a range of 4, and I do that the variable k dot resize to 6. So now when I resize here, I'm going to get 3, but when I resize to 6, I increase those elements twice to 6. Now the next thing you can do is sort. Okay, so I create an array here, which is also a 2-dimension n, and I print it out. Now I want to sort this element in this array, whether from smallest. Okay, so when I'm sorting here, it's going to arrange it from smallest to the biggest. Okay, so if I do sort n, I can just sort them. But now I want to specify on which axis do I want to sort. Now, if you do axis equals 1, then axis equals 1 will sort row-wise. But if you do axis equals 0, then it will sort column-wise. I've added a comment here so you can see that. So here, I'm doing axis equals 1. So it means that I'm going to sort row-wise. So this is the original array that I created, which is here. And now M here is the sort that I'm doing. So it means that on the row, it's going to arrange the elements from the smallest to the biggest on the first row and then on the second row. You can see that. Now, I mean, GitHub, I will demonstrate the other one for you to see. But it's simple. You can just change this to 0 at your own time, and you can see that it will also sort the elements from the column wise. Okay, bringing 1 up and then 4 down, just like that. Now, the next we'll look at is what arithmetic operations. And these are very, very also important. So you create an array here, and I want to increase the elements. Okay, I say, okay, now I want to increase the elements by 1. So I just create this array, which is D here. And then I assign another variable name, so D plus 1. So I want to increase the elements here plus 1. What is that? Is that in each of the elements is going to add 1 to all the elements. This is also something that you cannot do in lists. Because if you do that, it will only just create a repetition of what you have created in list. But in NumPy, you can just add them to that. So when I print F, you can see that here it was 1, now it is 2, and so on, 3, and so on. Now another thing I could also do is the same thing as ones. I just added 1, and then I created an array of all ones, and I added 1, and it changes them to 2. Now this is also another example that I created with the variable j and with an array range of 5. And I want to perform an operation. So I raise 2 to the power of what? The array plus 1 minus that array j that I created here. So yesterday, as we learned, the direction of, let me say the direction of the operations is you start with the exponent, then you come to the subtraction, and then you come to the addition. So when you print it out, this is what you get. And this is one of the most important things that you can find in array performance, used in performing operations. So the last topic we'll look at is some advanced operation with NumPy. And here I'm going to import matplotlib, which we are not going to go into details, but I just needed to plot, okay? But you're going to be taught today, give more details on that later on today. So what I needed is that I just needed to plot. So I import matplotlib.pl as plt. Now here, this plt, it works as the same as np, so it can be anything, all right? But the most important thing to note is that I need to generate some numbers, and linspace, as we said earlier on, helps us to generate numbers within an interval. So let's say this is my Cartesian plane. I have x and y, and on my x-axis, I want between 0 and 3. But between 0 and 3, I need 20 data points between that. On my y-axis, I want between 0 and 9. I then also need 20 data points between that. And plt.plot xy plots the points, okay? And then this plt.plot xy, then you can see that there is a string of 0 here, just indicates this yellow dots. All right. So that is one way you can do that. The next thing is maybe you want to print a 2D. This is 1D, one dimension, okay? So let's say you want to print a 2D, okay, let's say an image or something. I generate a random variables, okay, of 30 by 30, and I use plt.imshow, and I put my image here, which is the variable here. Now these things, see, map is a color map. Okay, when you Google, you can get a whole lot of regions of colors. Now, if I were to be able to work in Colab, you can just change this to a different color for you to see, maybe change it to a hot color or something. Now, this one here is being done by this command, plt color bar. You can decide to comment it, and you can have all of this. This just tells you the colors ranges that you have. So basically, that is the end of my presentation. I'm hoping everyone understands it, and sorry for the inconveniences with the technical glitches thereabout. Thank you for your attention. Betty will handle the exercises with you. Thank you. So Deborah, if you can hear me.
Yes.
Okay.
Okay. Thank you so much, Bernard. So I guess for the sake of time, Betty will just do the first exercises. Then the ones down probably will be best if they could try them on their own then. So we'll do the first exercises. So Betty, you can take over then.
Okay, Deborah. Let me try to share
Bethan, are you able to share your screen? Okay.
Okay. Uh, Hi, everyone. Can you hear me?
Hi, Bethan, we can hear you.
Okay, so thank you, Bernard, for the nice presentation. So we are going through the exercise. We will try to solve the first batch, and the second one, we can try it by your own. So for the first question, we will try to create a two-dimensional array. So the first row should contain the whole number, counting backwards, and the first and the second row should contain the even number. So we need to create this one. So I will need your suggestion on the chat, so now we can work together. If you have any question, you can put it on the chat and I will try to answer. I hope you understand the question. During the presentation, Bernard showed us how to create a 1D array, and here we are trying to create a two-dimensional array. In the first row, you have to so I can't see the chat. Any suggestion? Any suggestion?
Okay, to see this chart, just go up, you will see something should pop up for you. Just go up, take your mouse up a little.
Oh yes, I'm there.
Okay, then you see, maybe right click, no, just click, okay, you see somewhere where there's a chart.
Yes.
Okay, can you see the chart now? Okay, good.
Yeah, I can see it now. Thank you.
But your chart is covering the notebook. I think you might need to shift it somewhere else.
Okay. Is it okay now? So if there's no suggestion, I will try to explain how to create a two-dimension array. First of all, we need to import our Numpy. Import Numpy as NP. And now, let's assign our variable a, which is equal to np dot array brackets. Since it's a two-dimensional array, our TH said that we have first to put the first square brackets. And now, for our first row, what we will do, we have to specify to put just odd number backwards. And for our second row, we will put the even number backwards also. So for number that we can put here, so now it depends. It's just to be backwards number. So, but me, can choose the small number. Here, I can start from 5, because we are going backwards, 3, 1, and for my second row, we say that we will put even number backwards also. So I will start maybe from 6, 4, and 2. So let's run and see what's going on here. So now we can print our array. Yeah. So this is our 2D dimension. We can see in the first row, we have the odd number backwards. So we start from 5, 3, 1. And in the second row, we have even number starting from 6, 4, and 2. So this is how we can create a 2 dimension. The main point that you don't need to forget is that we have first to the NP array brackets. This is the definition. But inside, you have to add these square brackets first. And now, for each row, we have also to specify the brackets, the beginning and the end. That's how we can create the 2D array. I think now you get the idea. Is it clear? I say I can see Dominique. He tried to answer, but yeah, it's okay. But we ask backwards, so it's just to start from. No, Dominique, I think there's something wrong with your answer. But Gloria also. Zainab, yes, your answer also could be, okay, we can try your answer, because the one for Gloria, let's see what's going on with your solution. I think Gloria and Dominique, they have the same solution, so we can try it and see. So let's say our A is, let's call it B. We say NP dot array. So now, if you see, you suggest 1, 2, 3, and in the second one, you suggest 4, 5, and 6. Let's run and see. Yeah, there's something wrong. Oop. Yeah, there's something wrong. Why? Because you forgot to put the main brackets before to define this one is for the first row, this one for the second row. But because it's this 2D array, you have to add these square brackets here. So if we see now, yeah, there's no more error. And now we can print our B, which is equal to this. It's also good, but it's not part of the question. The question, we had some constraints here, like we have to, the first row should contain odd number, and the second one should contain only even number. But I think now you get it's clear now. Okay, so we can move to the second question. For the second question, they just ask us to find the shape, the dimension, and the length of our array that we create at the first question. So you can suggest to me how to get the shape of our array A, and how to get the dimension and the length of our array A. Any suggestion? Okay, now she said that you can do A dot shape for, let's see, okay, yeah, the shape of our 2D array is 2 by 3. It means that we have 2 rows and 3 columns. For this, for the dimension also, now suggest this, a dot n dimension. Let's run and see. Okay, so Zainab also suggests Dominique, Joanne, okay. Dominique suggests for len, we can use, say, len of A. Okay, good. Okay, Gloria also, yeah, that's good. Yeah, I can see now that people understand what we are doing here. So now I think we are done with the second question. So we can move. Okay, Edmond, thank you. Also, you give the nice, the good answer. So we can move to the third question. So this one, we deal with slicing. So let me read the question first and we can have any suggestion. So for the third question, try the different flavors of slicing. We will use the start, end, and step. Start by using the NP array. Try to obtain the slice of odd number counting backwards and even number counting forwards. So for this question, we have first to create our array using the NP arrange by specifying the beginning, like the start, the end, and the steps. And now when we have our array, we can now get the odd number from our NP arrange created, counting backwards, and the even number counting forwards. So I don't know if the question is clear. I will need your suggestion. Okay, Zainab, you ask, oh, okay, for the first question, there is no condition. So for question 1, yeah, for this one, we didn't put any condition. So it's just to say odd number. It means that we can create your own, another array. Let's say backward, I can start here, 15, 13, and 11. It's also a suggestion. So we didn't specify the range, so it was just random, your own suggestion. But the condition was just the first row should contain odd number and the second one should contain the even number, counting backward. That was the problem. I think there's no, you can choose what you want. And at home, you can practice with different values. So to move to the third question, we have to use the NP array to create an array, a 1D array using NP arrange. And now when we have our NP arrange, we can now find, to obtain the slice of odd number counting backwards and the even number counting backwards. So because of time, I can start. So now will give me the suggestion. Let's, I will say here, let's create just a simple variable by using NP arrange. So for this one, we say we have to use the start. So we have to specify the start, the end, and the steps. Let's first the end, and the step. So this one, when you say start, it means that you have to specify which number you want to start with. That's the meaning of this start. When they say using start, you know that, okay, I want maybe to start from 10. So this one will be your first number in your array. And the end is the last number, but in using the NP arrange, don't forget that, okay, when the last number, the end is always excluded, so it will not be part of the array created. And now the step is like the difference between two numbers. Maybe if you want the difference between the first and the second number to be 1, the step is 1. If you want it to be 2, you have to specify it. So what is what we are doing now. So let's say we want to start our array from 1, and the end to be, maybe let's take 10, and the step 1. So this one means the step is 1. Even if I didn't put step, it will work because by default is 1. But if I specify, I can, okay, this one I can change it to 2, to 3, it depends on what I want. So now let's run and see how we can create our yeah, there's the error and is not okay. There's something wrong here. So I have to okay, it's still giving me the same error. Okay, oh, I have to use stop. Okay, sorry. I have to use stop instead of end. Okay, so now I can print our array. See, yeah. So it's like if you see now that our array that we created has the start is 1, but the stop, I say that the stop, the end is always excluded. So that's why we stop at 9. And our step here is 1. So that's why the difference between the first and the second one is, the second element is 1. So if I change it to 2, yeah, you see now the difference. Yeah, there's one suggestion here from Roman. He said that we can use a range of 5 to -1 and 2. Let's try also this suggestion and see what's going on. We say np dot arrange, start from 5 to -1 and step -2. Yeah. So something I didn't specify, this start, stop, and end. Even if you don't put it, it will work. So here, let's run and see. Yeah, this one also is giving us the same. Yeah, okay, it's giving us the same a good result because the step here is -2. We start at 5 and we end at 3 because the difference at 1, the difference is -2. Okay, Thank you, Darius. Thank you, Didonius, Darius. Stop. Okay. So now let's see the last the question. Since we have our array, so we need now to slice to get the odds number, slice of odds number counting backwards. Backward, it means that we'll start from okay. There's also another suggestion here from Progress. Okay, yes, this one also, if we use the range 10 to, no, here we are dealing with, okay, a range 10 to 1. This one also will work because the step is 1 and it will work. There's no difference. This one also, it's a good example. Thank you for your suggestion. So now, how can we now slice? We want just, let's go back to our own example here. Okay, with our array T, we want just to get the odds number. The first of all, okay, we want to get odds number counting backwards. So it means that we want to get the odds number 9, 7, 5, 3, 1. So we want to get it backwards. What we did, I think our team tried to explain how can we get to do the slice from one array. What we can do, any suggestion from you? So I want just to print, I want to print 9, 7, 5, 3, and 1. So how can we do that? Any suggestion? So since we want to get backwards counting, so it means that we have to start, first of all, we can try to reverse our array. See? Our array T. Okay, we want to reverse our T, and now just get the odd number. The difference between the number will be 2. So that's why we will take all the row, but just 2 at step 2. So it's like the difference between the numbers here should be 2. So it means that we will not get the odd, the even number. It's only the odd number. How we do that? We can first get our T, all the elements, but step by 2 first. And let's see the results. Yeah, we have now what's 1, 3, 5, 7, and 9. But they ask us to print backwards. So it means that we have to start from 9 to 1. What we can do, we can add minus. So this one will try to reverse the array. So that is the results. I think everyone got the idea how we can get the odd number backwards. If not, you can put it on the chat so we can explain again. So I feel what I did, first of all, I want to get just the odd number and step by 2. So that's why I put here 2. Since I want to get it backward, that's why I just add -1, minus in front of 2. For me, like I want to reverse it by step by 2. Is it clear? Can we move on? And the second part of the question, we want to get also the even numbers counting forward. So for the second one, what we want to get the even number from our array T, we want to get 2. Okay, thank you. Now, give you one suggestion. So we want to print 2, 4, 6, and 9 because we want to print forward. So we want to print 2, 4, 6, and 8. So any suggestion? What am I supposed to put in this square bracket? To print 2, 4, 6, and 8. Okay, let's move on. I'll try to explain again. Gloria, she suggest something. NP array, NP arrange 1, 6, 2. I don't understand what to try to say. Let's say we have already our T here. Okay, Darius. He said that we can use 2. Okay, now 1, double 2, 2. Okay, let's see the result. Yeah, okay, good. Now, okay, who again? Darius. Okay, let's see the difference between the two. For him, he suggests from 2 to, yeah, you see, this one is for odd number. It's not for even. Yeah, for odd number, this one it will work. To get odd number forwards, I think you see the difference between the two. Who again? Albert is what I did here. It's giving us odd number, like forwards odd number. Salma, okay, your suggestion is good. Albert, okay, thank you. So, Gloria, I don't understand what you mean. You get this, you try the same question or what? Can you put your codes on the chat so I can see how we can solve your problem? But yeah, okay. So just let's do the last question. The last question is, okay, they give us already our 2D array here. Yes, yes.
I think the exercises are good, but we've spent so much time on the sesh tutorials, and
Okay.
we still have 2 more to finish. So would recommend that you let them try this on their own, and
Okay.
they feel free to reach out to us if they are having any challenge. I guess the solutions are in the notebook, right?
Yeah, exactly. Everything is there.
So yeah, so they could look at them on their own later.
Yeah, okay, that's good.
Okay, thank you so much.
You're welcome.
Okay, so
okay, I can stop sharing.
yeah, so I think we'll just take some 2 minutes break and then just continue with the next.
Okay, good.
Okay. Okay, thank you so much. Let me end the recording.